Hi everyone, this video about the EKT358 communication system and what we will study in this video. One of study in this video is modulation type. Type of the modulation have the two type is the continuous wave modulation and second is pulse digital modulation. Continuous wave modulation have the angular modulation and amplitude modulation. Angular modulation consists of the frequency modulation and the phase modulation. Another is the pulse digital modulation, have the analog modulation and digital modulation. Today we will focus on the pulse modulation. And what is the pulse modulation? Pulse modulation is the sampling analog information signal that's converting sample to the discrete pulse. And pulse modulation have the two types, is the analog modulation and the digital modulation. Analog modulation include pulse amplitude modulation (PAM) and pulse width modulation (PWM), and the last one is the pulse position modulation (PPM). Analog pulse modulation is the carry signal is pulse waveform and the modulate signal is where one of the carrier signal characteristic, either amplitude, width, or position, is changed according to the information signal. The first one talking about is the pulse amplitude modulation (PAM). The amplitude of the pulse carrier is varied according to the information signal, width and position constant in the pulse amplitude modulation. In the natural sampling, PAM signal is generated by using a pulse string called the sampling signal to operate an electronic switch or chopper. This produces sample of the analog information signal. Another one is the flat talk sampling. A sampler and hold circuit is used in the conjunction with the chopper to hold the amplitude of each pulse at the constant level during the sampling time. About transmission benefits of PAM signal. Pulse duration is supposed to be very small compared to the period sampling time between two samples. If on-off time of the pulse is same, frequency of the PAM pulse is maximum frequency equal to the 1/2 pulse duration, and the bandwidth required for transmitter of PAM signal will be equal or larger to maximum frequency. Example of a PAM. Based on the equation, we get the information W equal to the 3 kHz, pulse duration equal to the 0.1 ts, and Fs equal to the 8 kHz. Calculation the bandwidth request for the PAM transmitter. First, Ts equal to the 1/Fx. So answer is the 1.25 times the 10 power negative 4s. The second, pulse duration equal to the 0.1 times the Ts, and the last, the bandwidth equal to the 1/2 times the pulse duration. So the answer is the 40 kHz. The second modulation is the pulse density modulation (PDM), sometimes called the pulse duration modulation or pulse width duration (PWM). The width of the pulse is variant in accordance to information signal. Amplitude and position are constant. The width of the transmitter pulse corresponds to the encoder data value. PWM signal output is generated by the comparing summation result with the reference level. Third modulation is pulse position modulation (PPM). The position of the pulse are variant in accordance with some characteristic of the information signal. Amplitude and the width is constant. The higher the amplitude of the sample, the farther to the right the pulse is positioned within the time slot. About the transmission the bandwidth of the PDM and the PPM signal. PPM and the PDM need a rise time and a false time for the pulse in order to perceive the message information. The transmission the bandwidth of the PPM and the PDM is higher than the PAM. Let the rise time equal to the sampling time. The bandwidth is equal to the 1 over the 2 times the rise time. Example of the PWM and the PPM. The information is based on the example of the PAM. Find the minimum transmission bandwidth needed for the PPM and the PWM. The first rise time equal to the 1 over the 100 times the pulse duration equal to the 1.25 times 10 power of the negative 7 second. The bandwidth equal to the 1 over the 2 times time. The final answer is the 4 million Hz.
Now we are going to talk about the advantages and disadvantages of the 3-pulse modulation. For PAM, it can multiplex and only occurs in slots of time, where allowing transmission of other PAM signals to occur during its idle slot. It also requires precise synchronization of clocks between transmission device and receiving device. PAM disadvantages include requiring a large transmission bandwidth and power. It also receives maximum interference from noise. For PWM, it has a better noise performance than PAM, but it has a larger transmission power compared to PPM. For PPM, the amplitude is held constant, thus less noise interference, and the signal and noise separation is easier because the transmission power for each pulse is the same. Less power is required compared to PAM and PWM. Both PWM and PPM require a larger bandwidth than PAM. The table shows the difference between PAM, PWM, and PPM in amplitude, bandwidth, instantaneous power, noise interference, system complexity, and similarity to other modulation. The advantages of pulse modulation signal includes noise immunity, low-cost digital circuitry, and is able to multiplex with each other and allow digital stream storage with error detection and correction. Disadvantages of PM signal include great bandwidth required for both transmitting and receiving, and it requires special encoding and decoding method to increase transmission rate and is difficult to recover. It also requires precise synchronization of clocks between transmission device and receiving device.